Okay, we're live, so.
Okay. Did you muted?
No, you're cutting
No?
out again.
Can you hear me?
I
Now.
could do that.
You can hear me now?
Yeah.
Yeah.
Okay. So do you guys do the preparation for today?
Yep, I did.
Yeah.
All right.
Yeah.
So we can move right into part 2 then.
Yeah.
Yeah.
Okay. Um, okay. Are you ready?
Yep.
Okay. So the mean score of all GRE scores is 150.8 with a standard deviation of 8.8. So A, scores on the quantitative portion of GRE are approximately normally distributed with a mean of what and a standard deviation of what?
So 150.8 and 8.8, right?
Yeah. Right. That's right. I think, right? Because
Yeah.
we just give it to you, right?
Right.
Yeah.
They're just making sure we understand that, I think. So
Okay.
Yeah.
So then what proportion of the people who take the quantitative uh portion of the GRE will score above 165? So you take 165 minus 150.8 and then you divide that by 8.8
right.
and then whatever that is, you put it into the applet thing that they give you.
Right.
Mm,
1.6
136.
and then we're trying to find score above, so we need to shade the above it.
mm-hmm.
So we're going to get what? 0.0533, is that what we got?
Yeah.
Yeah, that's what I got.
Okay.
Okay. So then, if their score is in the 10th percentile, what would be their z-score? So then you put
So
in,
we put 10.10 in, right?
yep, and then shade below that.
Yeah.
And then you shade the bottom one.
Mm-hmm.
Yeah, shade to the left of it.
So it would be
Negative 1.282.
Yeah, that's what I got too.
Okay.
okay. I don't know why I didn't get that. Oh, because I didn't put the 10% in. That's probably why. Okay, got it.
Okay, and then D, what is the quantitative GPA scores in the 10th percentile? So this is one where we're solving for x. So we take what we got in C, and so negative 1.282 equals x minus 150.8 divided by 8.8, right?
Right.
Yeah.
And
So
then we solve and get 139.5.
So we go 8.8 times negative 1.282 plus 150.8.
Yeah.
And then, okay, that's not the right answer.
What'd you get?
Well, I just cleared it because I don't think that's the right answer. So we cross multiply the 8.8s out, then we times 8.8 by negative 1.282, right?
Yeah, and then you
Yeah.
add 150.8.
Then add 150. Yeah.
And then add 150.8. Okay, what'd you guys get?
139.5.
That's what I got.
I always screw up with the negatives. I don't know what the deal is. So the negative 1.28, it's negative, right?
Yep.
So you go 8.8 times negative 1.282.
Uh-huh. And then plus 150.8.
It still doesn't come out for me, and I know I'm just doing something weird. So if I go 8.8 times negative, and on a negative, I just put the minus on my calculator, right?
There should be a negative sign on your calculator. If you put minus, it will subtract it usually.
Okay, that's what I'm missing. Where is my negative sign, I wonder?
It's in parentheses. It should
Yeah. Next to the 0 or the... it depends on what calculator do you have.
It's up in the little... It's like the little things.
Do you have a TI-30X?
I have a TI-30X, yeah.
Yeah, so it should be... So you see the 0?
Yeah.
And then there's a point, and then to the right of that.
Oh, okay, that's a negative.
There's a negative sign to the right of
Okay,
that.
that will help me immensely because I keep on doing things and I'm just using my minus instead of my negative. So that's a problem. Okay.
Yeah, and that'll subtract it half the time. So.
Okay, that's bad. So we're at 139.5 is the answer?
Mm-hmm.
Yeah.
All right.
Okay. Colton, do you want to do number 7?
Yeah. So the mean speed of hydrogen at room temperature is 1,800 minutes per second with a standard deviation of 600 minutes per second. At room temperature, the mean speed of hydrogen particles is approximately normal with a population mean of, that's 1,800 like they gave us, meters per second, and a standard deviation of 600 meters per second, which is what they gave us too.
Mm-hmm.
So B. What is the probability that a randomly selected particle has a speed over 250 or 2,500 meters per second? So doing the same thing. So 2,500 minus our mean, which is 1,800, divided by our standard deviation, which is 600.
1.167.
Yeah, I put 1.167. Then we got to put it in our applet again.
Mm-hmm.
And then we're trying to find over that. So
Yeah.
we're doing the very last one.
I believe so. Yep.
So 0.1216.
Yep.
Okay.
That's what I got. Okay, C. What is the probability that a randomly selected particle has a speed that is less than 250 meters per second? So it's the same z-score, but we're just going to put to the left of that line that we had before.
And everything on the other side, right?
Yeah, everything on the other side.
Okay.
So that should be 0.8784.
Mm-hmm.
Good.
Okay. What is the probability that a randomly selected particle has a speed that is less than 150 meters per second? Or 1,500. I don't know why I keep saying 150. So same thing.
Mm-hmm.
1,500 minus our mean. This is 1,800. Divided by 600.
Less than 15.
So in this one, do we just do the left side, not the middle?
Yeah.
Why is that? Do you know why?
Yeah, because the z-score is negative, right, Mackenzie?
Oh, yes.
Yeah.
So we look at the line at the negative score. If the z-score was a positive 0.5, that would be our z-score.
Okay. So let's see. So I got 0.3085.
Yeah.
Yep.
Okay. E, what is the probability that a randomly selected particle has a speed that is between 1,500 and 2,500? So in this one in the book, they just found their probabilities differently, and then they subtracted them.
Yeah, so we just take C, our answer in C, and subtract our answer in D from that.
Yeah, that should be right.
Right. So 0.8784, and then you minus 0.3085 from it.
Yeah.
And so we
Uh-huh.
get 0.5699.
Yep.
Mhm.
Okay. F, what is the third quartile of speeds of hydrogen at room temperature?
So you type in 0.75 on the top.
Because that's the third quartile.
Mhm. And then,
Which part do we fill in now?
Third
So
quartile would be the 75th%, right?
So larger
Yeah.
than 75?
so then it gives you the z-score, which is 0.674.
Yeah.
And then then we solve for z, you know, that equation that we have. So 0.674 equals x minus 1800 divided by 600. And then solve for x.
I got 2,204.4 meters per second.
Mm-hmm.
Okay.
Yep. Okay, and then number 8.
Okay, what did you get for the answer one more time? 2,204.4.
0.4.
Yep.
Yeah.
Okay, good.
And then number 8, we just decide basically whether they're in a straight line.
Yeah. Yeah.
So for the first one,
No.
second is no too. What the third one? Do you think that's probably no too?
I thought it was no.
closer. They said don't worry about a couple outliers, but I'm not sure.
Okay. So C, you would say is normal.
Probably.
Yeah, I would say C is normal because it's pretty in a straight line.
Yeah.
Okay, and then D is definitely normal.
Mhm.
I don't know. What do you guys think about E? Because there is kind of that curve in the middle.
That one's hard. I would say not normal because of that curve.
Yeah, it's kind of like an S shape.
There's not just like a few outliers. It's kind of like a solid S shape.
Yeah. Okay, and then F definitely normal. Okay. So
On the answer key, it says E is not normal. So,
okay.
because of the little curve.
It says C and D are the only normal ones. Oh, and F.
And F.
Yeah.
Okay.
Okay.
Oh, so C is. It did say C was.
Yeah, C is
it
normal.
is normal.
Okay. All right. So are we ready for the quiz?
Yeah.
Okay. All right. You guys there?
Yep.
Yep.
Okay. The total area under a density curve must equal 1.
What?
Yeah. Yeah, it's 1.
Okay. Under certain circumstances, a density curve can drop below the x-axis. That's false, right?
False.
No, yeah, that can't do that.
Okay. A normal density curve is symmetric. True.
True.
Okay. Use the following image. So, okay, which of the following elements of the figure represents the z-score?
C.
Let's see.
Which of the following elements of the figure represents the probability that the z-score will be greater than 1?
B.
B would be that.
Yeah.
Okay. Okay, according to the 68-95-99.7 rule, what proportion of the data from the bell-shaped distribution will be within one standard deviation of the mean?
68.
That's 6. Suppose the z-scores come from a standard normal distribution. Use the normal applet to answer this question. What proportion of the values from this random variable will be between -1 and 1? Give your answer as a decimal, accurate to 3 decimal places.
Do we go and just onto ours and put the same area of 0.8413?
Yeah, I guess so.
And then it's asking us,
What portion of the values from this will be between -1 and 1? Shouldn't all of them?
Wait, I don't get what we're supposed to type into the...
I don't know, is that really what we're supposed to do? Okay, z-score, so we know the z-score is...
So that's going to be 1 standard deviation away.
Right? So it's in the 68th percentile, right?
Yeah, so I don't know, do we
Yes,
put 0.68?
Okay.
Oh, that's a good point. Maybe we do that. Let me look at it.
Because the next one is 2 standard deviations, and the next one is 3 standard deviations, which is a 68, 95, 99.7.
Use the normal applet to answer this question. What proportion of these values? So we don't really have any numbers. All we have is just a standard.
No, I think what we do is we type in for on the bottom 2 boxes, we type in -1 and 1,
Right.
and that will give us the top number.
Okay.
And then
But-
that's,
But what part do we shade? Do we shade the middle? Right? What? do we shade
Yeah. Yeah, it's the middle. Because it's between -1 and
the,
1.
okay, so yeah. All right. So
only
then
the
what they
middle.
give us
Okay,
is
so it's
0.6.
827.
Yeah.
So 0.683.
Okay, it says we do 3 decimal points, right?
Yeah.
0.683.
Okay. So,
Yeah.
so what? Are we good?
Yeah,
I
and
think
then put 2.
Okay.
Same thing.
So the same thing.
0.95.
4.
I think it would be 5.
5.
Yeah, 5. Yeah.
Okay. 0.955.
Yeah.
Yeah.
Okay. And then same thing for 3.
0.997.
Okay. Okay, so look carefully at your answers. What do you observe? The values match the rule. They double as you move from 1 to 2, or as the z-score increases, the area between those numbers decreases. I don't think it's... So
They
that-
matched the 98, 95, 99.7 rule.
Alright.
Because that is what it is. Something
Right.
within 1, 2, and 3 standard deviations.
Okay. Okay. Teresa, do you want to read the next one?
Sure. The amount of protein an individual must consume is different for every person. There's a solid theoretical ideas that suggest that the protein requirements will be normally distributed in the population of the United States. The protein requirements is given in terms of the number of grams of food quality protein that must be consumed each day per kilogram body of weight. Population mean requirement for adults is 0.66 grams per kilogram a day. The population standard deviation is 0.07 grams per kilo of protein kilogram. This information, if answer 14 to 17. What proportion of the population have a protein requirement that is less than 0.60 grams of protein per kilogram per day? So the 60th percent, is that what we're looking at?
No, I think we do.
Find the Z-score first, right?
Yeah, find the Z-score. 0.60 minus 0.66.
And then divided by
Divided by 0.007.
So we get 0.06 minus 0.66 equals
Okay, so negative 0.857.
857.
Yeah.
Okay. And then I think we put that in the applet, right?
Yeah. And what was it? Has less than that, so shade everything below that.
Yeah.
857.
Oops. So then it gives you 0.196.
6.
Okay. So then just take that for the next question and shade everything above what we did. So basically just the
We did
opposite.
the opposite.
And then so it's 0.804.
Okay.
Okay, and then we have to find another Z-score for number 15.
Okay.
So 0.7 minus 0.66 divided by 0.07, which is 0.571.
Okay.
And then everything less than that, I believe.
Okay, and then we're finding on that one. What are we finding on this one?
Everything less than that.
Then the negative answer?
Yeah. Well, I don't know. Let's see. Population that is less than 70%. I don't know. If that's
No,
right.
because the Z-score wasn't negative, it was positive, right?
Right.
So
So I think you fill in the shaded part in the middle too.
So we got 0.7160. Is that right?
Yep.
Wait,
Okay.
I didn't get that. Oh,
Okay.
I'm on the wrong Z-score. Whoopsies.
The
7.1.
Z-score is 0.571.
Yeah, so 0.716.
Okay. Yeah, that's what I got. Okay, and so we're supposed to do it 3 decimal points, so I put a 0 at the end. Okay. 0.716. Okay.
Yeah.
Okay.
Now find the probability of a person between 60 and 70.
Okay, so take
We already got those scores, right?
yeah, 0.804 minus 0.716, 0.088. Right?
Yeah, point zero. Is it 0.088?
Yeah. Is that what you got, Colton?
Yes. 1 second. My calculator just shut off.
Oh, okay.
0.716. Yeah, 0.088.
Okay, so now we have to find the 35th percentile. So type in 0.35 on the top. And shade everything below that. And then the Z-score is 0.385.
Yeah,
And so
okay.
then we solve for x. So 0.385 equals x minus, what is it, 0.66 divided by 0.07. That's all for x.
Yeah.
Okay, I got 0.687.
Yeah, I got 0.687. Yeah.
Okay.
Okay, I didn't. So just give me 1 second. So I'm timesing 0.07 times 0.0385.
No, it's just not 0.0385. Just 0.385.
Oh, okay, that's why I get it wrong. Okay. 0.07 times 0.385. Okay, 0.687.
Yep.
Okay.
And then same thing, but the 80th percentile. The z-score is 0.842. So just
Yeah.
the same thing. Okay, and I got 0.657. I mean 9.
Okay, I'm behind just a second. So I'm putting an 80th percentile up in the area.
Yeah.
Okay, this isn't working for me.
And then shade everything below that. And the z-score should be 0.842.
Okay.
And then you just do the same thing that we did for the last one, except with 0.842.
0.842 equals x. 0.66 times 0.07. Okay, so I got 0.719.
I got 0.659. What did
Okay,
you
so I put 0.07 times 0.842 equals plus 0.66,
Yes.
0.719.
Okay. Did I have-
719. Yeah, I got 719.
Okay. Okay.
0.719 is what I have too.
All right. Oh, okay. Yep. Got it.
Got it?
Yeah.
So the 80th percentile, we don't round that up to 72%. We just put 0.719.
Yeah,
yeah, I'm pretty
they've
sure.
been saying that you're supposed to round it to the 8th decimal place.
Okay.
Mhm.
All right, so I just gotta go make sure I didn't do something dumb as usual. So 3 is right, 4 is false, 5 is true,
Mhm.
C is the z-score, 7 is B, and that's if it's greater than.
Mhm.
8 is 68%,
Mhm.
and those we use the applet for, so hopefully those are all right.
Wait, so just to make sure that we typed everything in right, though, 9 is 0.683,
Right,
and then 10 is 0.955,
yes,
and 0.997.
yep.
Okay.
And then the values match, so that's
Mhm.
68 total, and then 13 is 0.196.
Yeah.
14.804.
Mhm.
Yep.
Do you put a 0 before things? Do you put 0.716?
I do. I usually do. But
I
I'm
did.
not sure if it matters or not.
Yeah, I did for some of them and some of them I didn't, so I think it's okay.
So 15 is 0.716. 16 is 0.088.
Mhm.
17 is 0.687. And then 18 is 0.719.
Yep, that's what I have.
Yeah.
Okay, are we ready to submit?
Yeah.
Okay. Yeah. Oh, 90%.
What did we get wrong?
16 and 17.
Okay. Wonder why.
17.
35th percentile. Hey, Applet's being weird. I put 35 at the top and it doesn't do anything. Oh, 0.35. That's why. Okay.
Yeah. So our z-score is 0.385.
Okay.
Oh, it's because it's negative
Which one's negative?
on the z-score for number
16?
17 for the 35th percentile one.
Yeah.
That
yeah.
is negative.
Is that the reason why we missed the other one too?
Well, no.
Okay. No, I don't know how that one would be wrong if we got the other two right. Well, okay. What do we put?
Find the
So-
probability around so
Wait.
between 60 and 70. Oh, that's the one we minused, right?
Yeah.
60, what the probability of 60 was what? 60 minus 0.66.
I don't understand how that would be wrong if we got 14 and 15 right.
Okay, but wasn't the probability score on the 0.60 a negative? I think we didn't consider that. Is that not true?
Well, we assumed that it was. Oh, it says right here. It says what we did wrong.
Oh,
It says 0.716 minus 0.196. So yeah, we minus the wrong ones. We minus the first one and the second one, but we needed to minus the first one and the third one. That's what it says.
Oh, so we just did it quick.
Yeah, we missed the 60. We did the above 60, not less than 60.
yeah. Okay.
Okay.
And I don't know why we missed the 35th percentile one.
It's because we used the wrong z-score.
Okay.
35th percentile for, and the z-score would be, what z-score would we put in there?
Negative 0.385. And so then if we would have done that, then the math would be different. So I'll do the math really quick. It gives us the answer, right, of what it should be? No? It doesn't.
Yeah. No, it doesn't on this one, so
Okay, but
I don't know if we'll figure it out then.
so
it would be 0.3501.
but if we do it differently, if we do it with a negative one, then the answer is 633.
Yeah.
Okay.
Oh well. Good job, guys.
All right.
Okay, awesome.
See ya.
Okay, bye.
Yeah.